Hi guys, welcome to my next tutorial. Today we're going to look at the intersection of two arrays. How can we write a program to solve this problem? So let's see what the problem is about. Given two arrays, you to write a function that computes their intersection. For instance, if you have this is the first array, this is the second one. If you check these two arrays, you will see that we have intersection. The only thing that intersects is 2 and 2 here. Those are the one that is common. And if you check this other one, 4, 9, 5 and 9, 4, 9, 8, 4, the only thing that intersect here, 9 intersect is common in the 2, 4 is also common. So we have 9 and 4. But we have a restriction on our result. Our output should each element in our result must be unique. That is, for instance, here we cannot have 9 9 9 4 4 4, so we can have 9 9 9 4 4 4, so it must be unique. But our result can be in any other. It can be 9 4 4 9. Looking at this kind of problem, a naive approach will be for us to say, okay, let me take each of these first element and take the other array. So this first element, if I pick this first element, I go into the second array and check whether it is there. Okay, and so if it is there, I drop that into a storage into my output. Then I go again and the second one to the second element here. I go to check here again and see if it is there, and if it is there, I have to check that it is not already in my output, because I must not have duplicates. If it is not already in my output, then I store it there. Then I continue to the third one. I take it here to go and check whether it is there. If it is there, that means it is an intersection. Then I check whether it's already in my output. If it is not already in my output, I had it. If it's already there, then I discard it. So if you go like that, you will discover that we are going to be having two for loops, and that means I will iterate this each time I pick an element here. I will go through this. Each time I pick an element here, I will go through this. That means I will be going in n by n time complexity, which will be n squared. But is there a better way of doing it so that we can have something that of less time complexity? Let's take a look at what we can do using hash. With hash, we can we'll be able to do this in time complexity of we should be able to do it in a linear space time complexity. Linear time complexity. The only challenge is we might have to be creating extra spaces. That's the only challenge. You might have to be creating extra spaces. So let's look at what we have. So now here you see that this is method intersection, taking the two arrays. So what we do is we create 3 arch sets of type integer. This is how we create an arch set in Java. So we have set 2, set 3, and we also create an array list. There's a reason for creating this array list. You will see that in a moment. Okay, now you see for integer x in nums1, that is in our first array, so we're using an enhanced loop. We want to get all the elements in our first array, which is nums1, and we add it to our first asset, the asset set. Then second, we get all the elements in the same way from our second array, and we add it to our second asset. So we have our two arrays in different asset. Now we can use an iterator to get the values inside of our asset. Now this is the way you get value from an asset, using an iterator. So you have these of type integer. Then now we're using the iterator to iterate through the values of our first set. Here we can actually pick any one of them. We can pick the first set or the second set. We can decide to pick this set, the first one here, or we can decide to pick set 2. Anyone, we're still going to result in the same answer. So here we're picking the first set that it iterate through the values in set, the first set. So we iterate through the value while itr.ask next to if we ensure that there's a next value. Then to get the next value, we use itr.next. We store that in a temporary value. The reason why we're doing this is because if you compare itr.next with this with set 2, we will not be able to get that value again to add, because by the time we say add itr.next, it won't add the previous value, because each call to next moves the pointer to the next value. So we need to store that current value in a temp so that we can do whatever we want to do with it before we go back again. So I hope we'll get that. So we store our values in temp, our current value of itr in temp. Then we check in our second set whether that value is contained in our second set. Now if that value is contained in our second set, then that means there is a duplicate. Then that's what we're interested in. So we add that value, that duplicate, into our output. Now you will see the reason why we decided that our output is declared as an array list here. The reason is array list give us the opportunity to be able to dynamically increase the size of our list. If you have used a simple array here, then we have to declare the size of the array, and we don't know what the size of the array is going to be. We don't know whether the size of the array will be the whole of sets, the whole of nums1 or the whole of nums2, or maybe it will be lesser. We are not sure. So we need something that will not confine us to a particular size. So that's why we use an array list here to initialize our output. I hope we understand that. So now we are adding the duplicate that is common to the two sets into our output. And if we see this one contains temp, if the second set does not contain the value that we're comparing, then this if will be false and there will not be any addition. Then we just go to the next one and continue like that until the itr does not have any other value. And you will see that actually corresponds to our intuition that if you check this one with this, and by the time I exhaust, if I'm picking this one as my set 1, by the time I exhaust this one, then there won't be any other comparison again, nothing to compare again. And if it is this one that I pick, by the time I pick this one, I check here whether it is there. Then I pick this one, I check, then there's nothing for me to check here, because any other value that is here, since this is exhausted, any other value that is inside the first the other array will not be a comma, will not be an intersection anymore. So I can just iterate through just one of the set, and once that is exhausted, that is all the duplicate I can get. So now once I have that, the specification of the algorithm demands that I return an array int. So you can see the return type is an array int. So for me to achieve that, I need to take back my array list, which is output. My output is an array list. I need to take it back into an array, a simple array of integers. So for me to do that, I create a simple array of integer and I initialize it to the size of my array list. This is how you get the size of the array list. Remember that output is of array list. So I get the size of that, then I initialize a counter, then I run through the array list with this enhanced for loop, and each value in the array list I put it into my new array, and because they are of the same size, I can be sure that this will run perfectly well. So all I just need to do is once the for loop finishes, I can just return this array, this array of integers. And that's just how you can find the code in my GitHub page. And the time complexity is big O of n. You will see that if you check, you will see that the time complexity that we go through, if you analyze this, you will see that each time we run through the array, either nums1 or nums2 in n time. So here we go through it n times, num2 will go through it n times in n times. So the time complexity will be big O of whatever is the maximum of the two arrays. So it's going to be the max of the two arrays. So it's going to be max of the two arrays. If the first one is n1 and the second one is n2, so it's going to be the bigger one of the other. Our space complexity is not going to be constant because we are creating extra spaces. So our space is also going to be linear in space, so it's going to be in n, because if you check, you discover that we are creating a new set. We're creating new set, and then the first set is going to take the value of the size of the first array. The second one is going to take the value of the size of the second array, and the third one at the maximum will go through the maximum of either of these two. Although we can try to make this more efficient by reusing, if it's possible to reuse some of the space. I can figure that out now. So but by looking at it, you discover that we'll be using space in comparison to the size of the array. The first one will be n1, the second one will be n2, because we need to add each of them. So here we are creating additional space at the length of nums2, and here we are creating additional space at the length of nums1. So it's also going to be linear to the maximum of whichever one is greater of the two. At the same time, here too we're creating a space for our array list. You discover that we're creating array list output. That's another space here, and this one is going to be at also, in the worst case, the maximum of the size of the two. So that is for the time and space complexity. Thanks for listening. Your comments are highly appreciated. If you don't mind, I'll just do a quick demonstration of what we have on our GitHub page. So this is the code that we have. This is the full-fledged code. I'll just do a quick demonstration of that. So this is a test instance. So here we have 1 2 2 1, and we have 2 2. So what is common to this is just 2. So we expect it to give us 2, and we don't expect duplicate. So we can do a simulation to see what we have for that. So let's see that. We compile. Hopefully we have a result. Okay, I I didn't send the output out in this list, but you can decide to do that. If you want to send the output out, you can decide to print out the output of let's see, we can do that quickly to not take us time. So we have this, we have return output 1. Okay, so we return this output 1 back to our result here. So, and that is going to be an array. So let's see how we can quickly modify that, because our output is going to be an array. So let's go through that, and for just we use an enhanced for loop there. Let's just see x int x. Let's see if we can use an enhanced for loop there. Out. Hopefully we have that work. So system out print ln to just print our result. Let's see that print our x out. So hopefully we should be able to have a result for that. Let's try that out. Debug. Do we have something in Java? What do we have there? What do we have there? Well, you can give this a trial, and I'll post the output on the GitHub page so you can check. Thank you very much.